Hello, everyone. Good morning, good afternoon, and good evening, dear authors and invited guests. Welcome to a technical session 4A. My name is Richa, and I'm the moderator of this session. On the behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you all are well aware, we are facing a new normal situation while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone who present on this digitally platform to go along with us for this conference in these unpredictable COVID-19 circumstances and making this conference more productive. Also, we wish their families to a protected time. We hope you will enjoy the knowledgeful and interactive digital sessions. Also, there is a special note for the presenter. You will be given 10 to 12 minutes for presentation and 3 minutes for question answer. And after 10 minutes, I will raise a gentle reminder to conclude the presentation. I request while the presentation is going on, other participant kindly be muted. And there's another request to the participant that you all stay connected with us till the closing remark. If you have any query and any updates, you can write it to me in a chat box. And just before we get started, I would like to introduce our session chair for chairing this session, Professor Shelja Patil. Shelja Patil is a Dean, Research and Development and Professor in Department of Electronic and Telecommunication at Rajashahi Sahu College of Engineering, Pune, India. She has received a PhD in statistical techniques in localization and tracking of wireless sensor network from Sardar Vallabhbhai National University Institute of Technology, Surat, India. Her main line of research is wireless communication and Internet of Things. She is a member of IEEE ACM and a fellow of Institute of Engineering. Welcome to you, ma'am.
Thank you, Richa.
And now we'll start our first presentation. I would like to invite our first presenter, Will, to present his paper on verification and validation for a project information model based on a blockchain.
Hello, everybody. I guess you can hear me and you can see me, right?
Yes, please.
Yes.
Okay, so let me just share my screen here, and you can see my screen as well?
No, right now, not yet.
Not yet. Okay, 1 second. Now?
Yes, please start the presentation.
Good, yeah. Well, thank you very much for accepting my paper for this conference. It is a privilege to be here with all of you. My name is Will Serrano. I am Honorary Research Fellow for UCL. And this paper, it is about the verification and validation for a project information model, which it is based on a blockchain. Let's see if I can move this. Well, what's the reasons of this paper, of this research project, right? So it is that we are experiencing that large construction projects, they are sometimes failing, yeah. And when I say failing, it is just mostly that they will have delays on changes in the specifications. There is a lack of single source of truth across the different project stages. And then, well, with value engineering and cost overruns as well, those are the several factors for why big projects normally they are not delivered on time, on budget. Yeah. Normally, these projects are being delivered as a traditional waterfall project management, yeah, which it is basically mostly on stages, where from one stage to another stage, it will be like a closed gap, so they cannot go back. Yeah. just as another reminder as well, we will have more agile approaches on project management that they have demonstrated success, which is agile is mostly based in focusing to deliver a minimum viable product that delivers an early return of investment, where it is a hybrid combination, a hybrid management approach between waterfall and agile, right? So that means that you don't have to wait too long till you see the benefits of your project, And then the good thing of agile and this project management, it is gradual, So when you deliver your minimum viable product, you don't stop there. So you make it better and better after each iteration, So that means that when you can include user feedback, and you can include as well market and business real-time information circumstances. With a waterfall, if a project lasts for too long, perhaps the technology that you specify at the beginning may be completely different than the technology or the user needs that you specify at the end. However, this agile approach requires the management and supervision of quality, in terms of requirements, aims, governance, and health and safety. Because, well, as the stages are not fully defined, then we can end up with an never-ending as well minimum viable product if the requirements are not captured properly or recorded. Then project information models, they have been already established to guarantee the success of an agile delivery. So it just assures that the data, such as requirements, are validated at this project stage. And as well, the validation confirms that the accuracy and compliance with the standards and completeness. So just going, this has been the quick introduction about the project delivery within the construction projects. So what we propose here on this paper, it is a model that consists of 3 layers of verification. So the bronze verification, you include all the data from your project, all the relevant data into a blockchain. Then the silver verification analyzes that data and extracts relevant topics via artificial intelligence and NLPs. And then finally, the gold verification, it just evaluates the sentiment and content classification, via as well AI and natural language processing. So as you can see, the more layers that we provide here, the data gets more and more analyzed and more valuable in the way that goes from you got all of it, then you got the few sentences that they are relevant, and then you got the key topic. So it is easier to search and easier to find relevance. The validation and verification model, I'm not going to go into the details here because, well, it is very mathematical. I'm going to say that you do have 2 rows. You got a data validation that approves that the data is authentic, and a data verification that, as I mentioned before, confirms that the data adds value to that information. So we will have adding value, and then that the data is authentic by checkers of that data as well. So eventually we get, as following the formula below, a score based on the number of validations and the number of verifications as well. And then we go to this bronze, silver, gold verification model, that it is a hierarchy on that data that will be introduced by the project information model. So in a nutshell, this is what we do. So you do have the raw validation and the column verification here, where different users of that blockchain within the PIM, project information model, will or either add value by extracting data. Those users can be humans, or it can be artificial intelligence as well, or it can be computers, or can we validate the data by saying that this is authentic, and the more validation, the more value that data will be, because more people will confirm that the data is genuine, that it is not fake. Then the experimental results, they have been based on UCL Perl that we have extracted from the web page meeting notes data following HTTPS and SQL. The private blockchain has been provided within UCL. So we will have mostly one miner on this time with different users that the mining is all within embedded within the blockchain, but the different users. They are users that validate and verify the data here. Then the NLP, we have outsourced that to Google Cloud Services that they provide entity analysis, sentiment analysis, and category analysis. Yeah. So the entity analysis just clusters the sentences into their topics. The sentiment analysis says how the score and the magnitude of that, if it is positive and negative. And then the category just categorizes that document into a category. Yeah. So that means that if you need to go back to your project documentation, it is easier to find information and easier to address the relevant topics or what it has been agreed on meetings as well. Then for those that you like numbers, I'm just going to go here into the experimental results. So you have different gateways here for different projects. Examples of the salience, score and magnitude, and the category of the different minutes for per that projects for the minutes here. So we have real estate, business and industrial, construction and maintenance as well, with the different components here. So this is what AI and the natural language processing from Google has told us. Yeah. And all of this information, it is stored into the blockchain. Yeah. So as you can see, we will have I have extracted data for, regarding the fees and the time for the different contracts within the blockchain and the different gas prices as well. So we can see the transaction fees as well are according to the size of the information and the mining time as well, with the V and V value. Yeah. So usually at the beginning, the fee and the time is larger because we introduce that into the blockchain, and then goes down, and it just adapts to the size of the block itself. Yeah. And then we have as well these similar results as well for the validation stage. So we have added into the blockchain the verification stages and the validation stages and the verification stages, both of them. And then the conclusions, it is that, well, we have provided a verification validation model based on a blockchain and distributed ledger technology, and the data services added are based on artificial intelligence and NLPs. Yeah. And we have applied that with real data based on a project for UCL, the Pearl project. And the blockchain, as expected, present a linear correlation between the gas limit and gas prices and transaction fees. And the mining time and the transaction fee are more relevant on the block structure rather than the volume of information installed with the block itself. Yeah. So the more complex the block is, the more expensive it will be. And if it is up to the user, if you fill it with information or not. Yeah. So this is it. This is what we have done. More information is on the paper. If you do have any questions, please let me know, and I will be happy to answer them.
Thank you, Will. It was a very wonderful research work. Nice presentation as well.
Okay, thank you.
I would like to know, have you compared your results with any other research work?
So this will be part of that. This is a very good question actually, and this is very good question. Yeah. So this is all innovative. So not any other research has done a model for a validation and verification for a data marketplace or for data. So this is innovative. So there are not any other research that we can compare to. However, part of the future research that I'm working at the moment, it is we have done a private blockchain, which based on Get Ethereum. It is on the which it has been hosted on UCL. So future research work will apply other blockchains, layer ones blockchains, like for example, Solana, Cardano, and the different layer one protocols, and it will compare the performance in terms of mining time, gas prices, and transaction fees between all of them. Yeah. So this it is another extensive piece of work that it will be added on what we have done. Yeah. So this has set up the scenes to develop a model and to analyze that it works and data can be stored into the blockchain. The next phases, the next advanced future work will be to compare the Geth that we have used with other commercial blockchains based on layer one protocols.
Okay, great. Thank you.
Okay, thank you.
All the best.
Thank you so much, Will. It's very nice presentation. And now I would like to invite our next presenter, Shikha Yadav, to presenting her paper on enumeration of LCD and self-dual doubles circulant codes over the equation.
Thank you, ma'am. Is it visible, ma'am?
Yes, it is visible.
Okay. Hello everyone, I am Shikha Yadav from IIT Patna, India. The topic of my presentation is enumeration of LCD and self-dual double circulant codes over the ring FQV by V square minus 1. This is the outline of my presentation. First of all, I will present communication diagram followed by some basic definition. Then I'll provide some results followed by conclusion. Finally, I will provide some references. Communication diagram. Codes are used around us in many forms, like we use them for calling through mobile. They are also used for getting images from space through satellite. And this is a communication diagram. So suppose we have some message, then this message will be generated from message source and it will first go to encoder. Encoder will convert this message into some suitable form to passes through channel, which is noisy. So because of this noise, this message gets distorted and gets some errors. And this error message containing error will go to decoder and decoder will detect error present in this message and will correct them. And then finally, this corrected message will go to the user. Now we define code. Suppose FQ is a finite field with Q elements. Then a code over FQ is basically a set of sequences with symbols from FQ. And if each element of the code C is of fixed length, then we call this code C as a block code. If C is a block code of length N over FQ, then it is basically a subset of FQN, where FQN denotes the set of N tuples with each component entry from the finite field FQ. For example, this code C equals to 011 101 110 is a block code of length 3 over the finite field F2. Code words. A block MN code consists of two functions. One is encoding function, another one is decoding function. Encoding function sends an M tuple to N tuple, while decoding function sends N tuple to M tuple. Here, the elements of the image of the encoding function are called as the code words. Now we look at linear codes. So first we see that this FQN, which is the set of N tuples with entry from FQ, we define two operations over this set. One is plus, which is component-wise addition, and another one is star, which is component-wise scalar multiplication. Then with respect to these two operations, this set forms a vector space and its subspaces are very useful for us, which we'll see in the next definition. So a linear code C of length n and dimension k over a finite field FQ is basically a k-dimensional subspace of the vector space FQN. And here the notation that we use for a code of length n and dimension k is in square bracket n comma k. Hamming distance. Let C be a linear code, then the Hamming distance between any two code words x and y is basically the number of components where x and y differ, while the minimum Hamming distance for the code C is defined as the minimum of all possible Hamming distances between distinct pair of code words. And the notation that we use for nk code with minimum distance d is in square bracket n comma k comma d. For example, this code C equals to 000 011 101 110. It is a 322 linear code over F2. That is, it is a code of length 3, dimension 2, and minimum distance 2. Generator matrix. Generator matrix is used to store code in very less space in comparison to storing all the code words. And for nk code, that is a code of length n and dimension k, a generator matrix is basically a k cross n matrix whose rows forms a basis for the code C. For example, the generator matrix for this code C is 0, 1, 1, 1, 0, 1. Now we define Euclidean inner product and we'll study some particular type of codes with respect to this inner product. The Euclidean inner product of two elements x and y is defined as the sum of component-wise product, that is summation I varying from 1 to n xi yi. Now dual of a code. For a linear code C, its dual is denoted by C perp and it is basically the collection of all those vectors x in FQN whose Euclidean inner product is 0 with all the code words. And if C is a code of length n and dimension k, then its dual code will also be a linear code of length n and dimension of this dual code will be n minus k. Self-dual code. If a linear code C is equals to its Euclidean dual code, then we say such codes as self-dual codes. And if intersection of a code with its dual is trivial vector, then we say such codes as LCD code or linear codes with complementary dual. Now we come to double circulant code. Double circulant code is basically a linear code whose generator matrix is of the form G equals to horizontal join of I and A. Here I is the identity matrix and A is a circulant matrix, that is a matrix whose rows can be obtained by the successive circular shift of the previous row. Now structure of this ring. Here we take the ring R equals to FQ plus VFQ under consideration. Elements of this ring are of the form A plus BB, where V square is equals to 1. Then using the Chinese remainder theorem, we can decompose this ring as the direct sum of 1 minus V by 2 FQ, direct sum 1 plus V by 2 FQ. Now we define a gray map. This gray map is used to obtain codes over finite field from the codes over ring. So psi is a map from Rn to Fq to the power 2n, which is defined as psi of y1 plus vy1 dash plus y2 plus vy2 dash up to yn plus vyn dash equals to y1 minus y1 dash, y2 minus y2 dash up to yn minus yn dash, y1 plus y1 dash up to yn plus yn dash. Now our objective is first to find necessary and sufficient condition for a double circulant code over R to be LCD or self-dual. Then we do the enumeration of self-dual double circulant codes and LCD double circulant codes over this ring R. So for doing the enumeration and to obtain necessary and sufficient condition, we first need factorization of the polynomial x to the power n minus 1. In that we use some terms like reciprocal polynomial, self-reciprocal polynomial. So we now define that. So for any polynomial fx of degree n, its reciprocal polynomial is defined as f star x equals to x to the power n f of 1 by x. And if fx is equals to f star x, then this polynomial is called as self-reciprocal polynomial. Decomposition. Here we consider n to be an odd positive integer. Then the factorization of x to the power minus 1 is a times x minus 1 product I varying from 2 to s gix product j varying from 1 up to t hjx hj star x. Here a is a unit element in the ring R. Gi are self-reciprocal polynomials of degree 2ei and hj star is reciprocal polynomial of hj and degree of these polynomials are dj. Now again, by using the Chinese remainder theorem, we can decompose this ring Rx by x to the power n minus 1 as R direct sum I varying from 2 to s R2ei, direct sum j varying from 1 up to t rdj, direct sum rdj. Here capital R small r equals to fq to the power small r plus vfq to the power small r. Here v square is equals to 1 and r is equals to 2ei or dj. Now we obtain necessary and sufficient condition for double circulant code over R to be LCD or self-dual. For that, we first need the decomposition of a linear code. So any linear code over this ring R can be decomposed as C1 direct sum, I varying from 2 to S Ci, direct sum J varying from 1 up to T, Cj dash, direct sum Cj double dash. Here C1 is a linear code over the ring R. Ci are linear codes over the ring R2ei for I varying from 2 to S, and Cj dash and Cj double dash are linear codes over the ring Rdj for J varying from 1 up to T. Now, this lemma gives us the necessary and sufficient condition. So suppose C is a double circulant code over R, which is given by this equation 1, and alpha 1, alpha I, alpha j dash, and alpha j double dash are generators of the codes C1, Ci, Cj dash, and Cj double dash. Then the necessary
Dear presenter, sorry to interrupt. You have last 2 minutes.
Okay. Then the necessary and sufficient condition for this code to be self-dual is 1 plus Ce1 square is 0, 1 plus Cei to the power 1 plus q to the power ei is 0, 1 plus Cdj dash, Cdj double dash is 0. And the necessary and sufficient condition for this code C to be Euclidean LCD is 1 plus Ce1 square is a unit element in the ring R, 1 plus Cei to the power 1 plus q to the power ei is a unit element in the ring R2ei, and 1 plus Cdj dash, Cdj double dash is a unit element in the ring Rdj. Now, to do the enumeration, here we note that n is equals to
Sorry to
1
disturb.
plus. Yes, ma'am.
Can you focus on results of this implementation?
Okay, ma'am. So using the previous necessary and sufficient condition, we do the enumeration of self-dual double circulant code. So the total number of self-dual double circulant codes of length 2n over the ring R is given by this formula 4 times product I varying from 2 to S q to the power ei plus 1 square, and product j varying from 1 up to t q to the power dj minus 1 square. And similarly, we obtain the total number of LCD double circulant codes of length 2n, which is given by this formula. Now, this is the conclusion. So suppose Cn is the family of codes with parameters n, k, and dn over finite field fq, and we denote the relative distance with delta and rate with rho, and rho is basically limit supremum of kn by n, and delta is limit infimum of dn by n. Then if q is an odd prime power and delta is greater than 0, then there are family of double circulant codes, which is self-dual of length 2n and code rate is 1 by 2, and whose gray image have relative distance delta such that HQ delta is strictly less than 1 by 8. Similarly, we get a family of double circulant LCD codes of length 2n with rate 1 by 2 and whose gray image satisfy HQ delta strictly less than 1 by 4. Here HQX is the Hilbert entropy function, which is defined as this HQ at 0 is 0 and HQ at x is given by this equation for x varying from 0 to 1 minus 1 by q. Here are some examples that we have obtained. This first column represent m such that length of the code is 2m, and second and third column represent a1, a2 such that the generator of the polynomial c is 1 comma ax, where ax is equals to a1x plus v a2x. And here psi c is the image of the code c, and here are some references. Thank you.
Thank you, Shikha.
Thank you, ma'am.
It was a nice presentation. What are the other double circulant codes used in communication channel?
Actually, there are quadratic double circulant codes also.
Okay. Then how do you check the efficiency of your code that you have developed? You need to compare these code implementations in communication channels, no?
Okay, ma'am. Actually, we check the rate of the code as suppose k is the dimension of the code and n is the length. Then the rate of this code is k by n. So we should check that this should be maximum or higher in comparison to other codes.
Okay, can you please show that slide where you have shown the results?
Okay, ma'am. Is this one or table?
Table one.
Okay.
This is what actually talks about.
Yes, ma'am.
Okay. So your proposed code is giving better performance as compared to others, right?
No, ma'am. Actually, I have just obtained some codes.
Okay, okay. All right. So here I suggest you to please compare your results with the existing researchers' work so that we can check for the efficiency, how these are working in the communication channels in eliminating noise.
Okay, ma'am.
Hmm?
Okay, ma'am.
All right. Yeah. Thank
Thank
you.
you.
All the
Thank you,
best.
ma'am.
Thank you, Shikha, for this presentation. And now I would like to call our next presenter, it's Patrice, to presenting his paper on Principles of Assurance on Corporate Governance of ICT.
Good morning. Thank you, ma'am, for that introduction. Let me just quickly share my screen. Fantastic. Can I just get a confirmation whether you can see my screen?
Yes, it is visible, right?
Fantastic. Okay. Good morning, everyone. Thank you so much for attending, and thank you for having this opportunity to be part of this conference. And I guess my presentation this morning will be slightly less technical than the others, but also something that is very important. And my name is Petrus Delport, and I'm presenting from Norway, from the Norway School of Technology and Digital Media, and Principles for Assurance of Corporate Governance of ICT, which is something that we're quickly going to take a look at, then we're going to move over to some principles. So the very first thing that we want to ask ourselves is, what is corporate governance of ICT? Now, corporate governance is something that started back in the 80s with some of the big organizations. Some of you heard of Enron, etc., which basically came to a place where we said that we need to make sure to hold the board of directors of any big company accountable. And that needs to be in HR, that needs to be in finances, that really needs to be in all different spheres. So that brought us to a place where we said ICT is also something that we need to focus on. And for that reason, we have corporate governance of ICT. So according to the ISO 38500, which is the very well-known or prominent one for corporate governance of ICT, it states that corporate governance is a system by which the current and future use of ICT is directed and controlled. What can we gather from this? Basically, what we can gather from this is that we have to do three things. So when we are discussing or investigating ICT in an organization or enterprise, if you will, we have to evaluate, firstly, that the need of ICT is met, and we also have to direct it. In other words, make decisions as to what are we going to do with it. But after that, we do not stop. We need to control it. And the control here really talks about the monitoring, making sure that what we are implementing in terms of ICT is done correctly, that we are achieving our objectives, our strategic objectives in a business sense. So now that we understand this, how does it actually look for us? So if we have a board of directors, as we can probably see over there, we need to get from a decision to implementation. And there's multiple things in terms of corporate governance in general. There are multiple things that need to happen. Firstly, we or the board of directors needs to evaluate certain things. What they need to evaluate is they need to evaluate the economy, they need to evaluate changes, laws, risks, goals, etc. A bunch of different things that they need to sort of evaluate, and their decisions really are focused on that. Changes, we're talking about the pandemic that we are currently in, economy changes, we're talking about anything that happens in the economy, changes, stock markets, etc. Laws. Very good example here is the introduction of the GDPR in 2018 in the European context. Risks, just the fact that something like a pandemic is a risk, or not being compliant to GDPR is a risk, and also our goals. What are we striving towards as being a producer of something? So once the board of directors evaluates these different areas, then they can what we call direct. And once they direct, they make decisions. These decisions are really the things that we need to implement. So this is where they would take security seriously. This is where they would make investments in ICT, etc. But to a large extent, we know also from governance and the management side that the management are the ones that typically implement this. This is done in general in your information security management systems, etc. That helps attain your security and the bigger governance sphere as well. But we don't stop there. As we said, a very important part is the control leg. And this is what calls or makes this entire thing a process. It's the idea that we can check up to make sure that we have done what we are supposed to be doing. In a nutshell, this is called corporate governance for ICT. Now, if we refer to a lot of resources out there, in case COVID 2019, COVID 5, COVID 4, doesn't really matter at that stage, but we end up with what we call the 7 enablers of governance. We know that we are going to have some sort of processes that needs to be there in an enterprise. We need organizational structures. In other words, who communicates to who, what are the hierarchy, etc. We need culture, ethics, and behavior, making sure that the entire organization runs as it should, specifically in terms of ICT. There will be principles, policies, and frameworks. Without policies, we would not know what to do. Without the framework supporting those policies, we won't be able to implement it in itself. Information flows, meaning the outputs of some processes will become the inputs of other processes, and everything needs to be connected together. But we also have a service infrastructure and application, making sure that this infrastructure is running correctly. And then lastly, the people, the skills, and the competencies that bind everything together. So now that we understand that this is governance and corporate governance, we can see, but how do we know that it is run effectively? How do we know that it is actually done? Now, as we highlight, control is the only way which we can really provide what we call assurance. Assurance and auditing is very closely linked together, but assurance talks about the ability to make sure that we control or monitor everything in governance, really saying that those 7 enablers, we want to control that those 7 enablers are run optimally, that it is providing the correct thing. So assurance is the next thing then that we need to understand. Now, according to the International Auditing and Assurance Standards Board, an assurance is an engagement in which a practitioner, think of an auditor for instance, provides some sort of a conclusion designed to enhance the degree of confidence for the intended users, other than the responsible party, about the outcome of an evaluation. So basically what we can gather is that an assurance and engagement is there to provide some peace of mind, some confidence, so that you know either these countermeasures or whatever you are providing assurance on, governance in our sake, is either effective or it is not effective in achieving its ultimate goal. And that is what assurance is all about. So if we can say it, referring to the ISO 15408, we can really say that an owner, and this is somebody that, for instance, the board of directors, for instance, they require assurance. Now, the only way we can provide those assurance is by some sort of evaluation. Now, the owners needs assurance to make sure that a countermeasure is firstly correct, that we have it, and then also making sure that it is correct, that it minimizes the risk that it has to a specific asset. But not only should we know that it is correct, we should also make sure that it is effective and therefore minimizes those risks. So if we take a look at an analogy, we can have a room with a door, and say, for instance, we have an asset inside of the room. There's only one way to enter the room. What we need to do is we need to make sure to look at one countermeasure. For instance, let's consider that lock. What we need to do is we need to make sure that that lock exists. If we don't have a lock, we can't lock the door and the asset will have a risk. But we also have to make sure that that lock is installed in the correct place. It's installed on the door. There's no use in having it lying in a cupboard somewhere. Lastly, as well, we need to make sure that it is the proper lock, that it is not the same lock that you will use for a normal cupboard door, but it is something that we can use to protect gold. And that's, to a large extent, are three key elements for assurance. The functionality, talking about the existence, it's correct, and also talking that it is effective, it is achieving its intended purpose. Now, in this paper, what we did is we looked at various different sources, the ISO standards, etc., and we extracted different principles in order for us to provide assurance on corporate governance of ICT. Now, visualizing this to some extent provides us with an overview picture where we can see that there are multiple elements that we need to consider. Firstly, there's some sort of a relationship because there's certain individuals or entities that need assurance. It is part of their fiduciary duties to make sure that the investment that they have, that it is providing optimal return on investment. And we have the assurance professional that will actually conduct. So this will be typically an assurance auditor of some sort. And what we have is we have the subject matter. Now, the subject matter is really what are we trying to provide assurance on? Think of our analogy. This is the lock. We are trying to provide assurance that this lock is good enough to provide security for the gold, but also suitable criteria. How do we know what this lock should actually do? And this is what we call a baseline. We should know what a basic lock should be if it needs to protect, for instance, gold. We need to execute and do the actual assessment. This is where the subject matter is compared to the baseline, and we can gather some sort of a maturity to understand whether we are meeting the criteria or not. And the last part is then also the report or the conclusion of the entire assessment. We can also identify that this normally happens in 3 phases, as we call it the 3-phased approach of assurance. Phase 1, determining the scope. Phase 2, really doing the assessment and comparing the subject matter and the suitable criteria. And then number 3 is phase 3 is the reporting, the conclusions, where everything happens. So in summary of the principles that was extracted, which we could then use to build a framework for assurance of corporate governance, is firstly, we will have 2 parts. We need, firstly, the governance. It needs to be implemented. And only then can we actually provide assurance on it. Very important part of it in itself. There needs to be various certain concepts that is specifically applicable to assurance. Now that's things called target of evaluation, security target, and so forth, which is explained quite in depth in the paper in itself. But nevertheless, these concepts need to be part of any attempt to provide assurance. We know that there will be a 3-party relationship, which means that we will have different entities that has roles and responsibilities in providing assurance for corporate governance. We also know that we need a baseline. If we don't have anything to compare it against, how will we know whether it's successful or not? Number 5 is also we need to make sure that we look at the functionality. Does it exist? The countermeasure. Is it correctly implemented or installed? And then lastly, is it effective? In other words, is it achieving its intended purpose? Number 6, we know that we have the 7 enablers, and this really links onto the preparation and implementation, because this is what, in terms of governance, this is what we are going to investigate. And then lastly, we know that this will happen over a 3-phase process: the scoping of it, the actual assessment, and then the reporting thereof. Now, which is beyond the scope of this paper and presentation, but these principles were actually taken in which we developed a framework. And this is just a visual sneak peek at a framework which we developed specifically for local government, but nevertheless, in order to provide assurance on the implementation of corporate governance. So that is
sorry for
everything
interrupt.
on my side. Thank you for listening, and I will open up the floor for any questions.
Thank you, Petrus. That was a nice detailed analysis on principles for assurance of corporate governance of ICT. My question is, so what are the challenges in implementation of the system that you've suggested just now?
So a very good question. Thank you for the question. And I would say the very first or difficult challenge that we have is for individuals to actually commit or acknowledge that they need assurance. This is something that we see. This project was specifically launched for local government, and what we see is we don't have the commitment from the upper management to really commit to doing this, and investing in this. So this is a big challenge in itself. Since the introduction of the GDPR in 2018, this has changed, because now obviously they can get fined tremendous amounts. So we have seen in the last 3 years or so, we have seen a change, but originally that was one of the biggest challenges we faced.
Okay, thank you, Petrus.
Thank you so much.
Thank you, dear presenter. You have a very nice presentation. And moving ahead, I would like to invite our next presenter, Veena, to presenting her paper on the role of telecommunication technology during COVID-19 pandemic in Indonesia.
Okay, thank you for the opportunity. Can you hear my voice?
Yes, I can hear you.
Yes, we can hear you.
Okay, good morning, everyone. Thank you for the opportunity and honor to meet you all here. In this opportunity, I would like to present about the role of telecommunication technology during COVID-19 pandemic in Indonesia. But first of all, I would like to introduce myself. My name is Vina Pujanti and I'm from Indonesia. I'm student of the telecommunication system study program at the Indonesia University of Education. And this is the outline for presentation today. The first is the introduction, then the role of telecommunication in education sector, and the role of telecommunication in economy and in healthcare sector, and the last is the conclusion. The first is the introduction. The world is facing complications caused by the coronavirus disease or COVID-19, including Indonesia. COVID-19 case continue to increase, recorded in April 2021, positive case of COVID-19 reached 1.64 million case, and recorded in February 2022, positive case of COVID-19 have reached 5.29 million case. The Indonesian government implements social distancing and physical distancing policies to prevent more COVID-19 infections so that outdoor activities are limited. The policies taken by the Indonesian government has made a great impact on the use of technology in many areas of life, including education, economy, and healthcare sectors. And one of the most important technologies in this time is telecommunication technology. And this article will describe the role of telecommunication in the fields of education, economy, and healthcare in more detail. The first sector is education sector. During this pandemic, telecommunications have an even more crucial role in education sector. The learning system is transformed into an online learning system, and we can see from this picture that learning system is transforming from offline to online. According to Final FL 2020, limiting physical contact between college students to cut the virus transmission is the reason why schools closed. With this education system transition, the role of technology is becoming even more needed and crucial. Examples of the use of telecommunication technology in the education sector is mobile learning. M-learning refers to IT tools in the learning process because it can be accessed by electronic gadgets such as laptop, smartphones, and tablets. M-learning is part of e-learning. They are the primary means in the continuation of distance learning. And in a study of e-learning during COVID-19 pandemic conducted by Rada et al. 2020, out of 175 respondents, 70.86% of them agreed that e-learning is able to broaden horizons, which is indicated by blue color on the chart. Furthermore, 82.86% of them admitted that e-learning improves their independence learning abilities, which is indicated by orange color on the chart. And this is example of online platforms as the technology assistance in online learning. There is Zoom Meeting, Telegram, Google Meet, Line, Google Classroom, WhatsApp groups, and others. And in our campus, Indonesia University of Education, in giving quizzes or exams, our electors take advantage of several online media like Google Forms, quizzes, Kahoot, and others. But there are many challenges in implementing technology in education. The first is educators and students' skills to operate the existing technology according to DABAG 2007, and internet connection or unstable network. And the last is the difficulty of two-way communication between educators and students. And the second sector is economy sector. Telecommunication has a crucial role in economy sector. According to Putra 2020, the Indonesian Minister of Finance said that when COVID-19 broke out, the Indonesian economy declined to minus about 5.3%. Therefore, the internet is a vital resource to counter the decreased economy. With the internet, producers and consumers can communicate without being constrained by distance and time. And this is the picture of Digital Data 2020 launched by We Are Social. The first picture explained that 2.42 billion people or 4.30 billion people have internet access, and the population that use social media is around 2.14 billion people. And the second picture explained that 88% of online transaction players are Indonesian citizens. And according to Sijifra and Molnar 2020, the role of Industry 4.0 in economic sector is as follows: to ensure more business survive, to help restoring business to normalcy, to provide a platform in developing various medium to long-term business. It is certainly good for future business opportunities through e-commerce utilization. E-commerce exchanging products, service, or information via the internet. And this is example of social media and e-commerce that use for buying and activities, buying and selling activities. There is TikTok, Instagram, Facebook, Shopee, Tokopedia, Bukalapak, Akulaku, and others. And here the advantage and challenges of online stores for vendors and buyers. The advantage for vendors are vendors do not need a real shop. Renting cost is not needed. Marketing can be done by making digital flyers or pamphlets with persuasive sentence. And online stores also commonly make use live streaming feature to conduct promotion. And the advantage for buyers are all of e-commerce provide the best service to meet a certain standard like quality control, refund guarantee, and others. And in certain events, e-commerce often provides many attractive bonus such as discounts, cashback, and various features. Vendors and buyers can interact directly through comments feature in live streaming promotion. And the last is several online stores must have displayed much feedback from other customers. It certainly makes it easier for buyers to choose quality products. And the challenge is the risk of data leakage and privacy violation may happen. Some people can use our personal data to make fraud, which is criminal and can make our name bad. And the last sector is healthcare sector. During pandemic, health service should be conducted even more carefully by considering a very strict health protocol to avoid infection. By using technology, medical personnel can examine patients remotely so as not to cause mass gatherings. Technology also can help all people to share information about the COVID-19 virus. And this is the innovation and the challenge of telecommunication technology in healthcare sector. The first innovation is an online health consultation system through smartphone application like HaloDoc, YesDoc, AlloDoctor, and others. And the second is artificial intelligence or AI combined with point of care diagnostic to perform independent testing after someone exposed to COVID-19. And the last is AI-based cameras developed in China that can identify places and people infected with the virus. And the challenge is the degree of accuracy both in online health consultation and robotic health treatment. Some patients might still feel the need of human-to-human interaction to care for their bodies. And this is example of online health consultation, and this is the view of HelloDoc site, and this is the view of our doctor site, and this is the view of YesDoc site. And this is the picture of a robot at a hospital in China. From the presentation, I can conclude telecommunication technology is pivotal to many activities during this COVID-19 pandemic, especially to education, economy, and healthcare sector. And this is the role of telecommunication technology and its challenges for each sector. The first sector is education, that telecommunication technology allows education to be carried out remotely and individually through e-learning. But the extent of digital literacy to operate the technology is the challenge. The second sector is economy, that online business or e-commerce that carry out through a special technology-based platform. But it has a challenge, namely the risk of personal data leak. And the last sector is healthcare sector, that telecommunication technology has a role in healthcare sector. Many innovations are created to address health problems during this pandemic. Examples, online consultation, but it also has the challenge, namely the diagnostic accuracy. Therefore, the utilization of telecommunication technology still needs to be socialized and developed. Thus, its application will be more effective because it still enables and even improves the education, economy, and healthcare service after the COVID-19 pandemic. And finally, it is safe to say that where there is human activity during a pandemic that requires internet connectivity, that is where telecommunications can come to play. That is all for my presentation. I will warmly welcome any question or feedback from you. Thank you so much.
Thank you, Veena. That was a nice presentation. My question is, what is role of Industry 4.0 and Education 4.0 during COVID-19 pandemic? Uh, am I audible?
Can you repeat your question?
Yeah. So, what is role of Education 4.0 during COVID-19 pandemic?
I think there is a policy cyber role of Industry 4.0 in education during pandemic, and it also has the challenge of for students to doing of online learning system in this pandemic.
Okay, thank you, Veena. That's all from my side.
Okay, thank you, ma'am. Thank you for your all attention, and I'm sorry for the noise during my presentation. Thank you so much.
Thank you so much, Veena, for your nice presentation. And now I would like to call our next presenter. It's Kirti, to presenting her paper on investigation into secure ISC practices.
Hello, can I confirm with the host whether I can start?
Yes, please start.
Okay, give me a second to share my screen. Am I audible?
Yes, you're audible.
Okay, so I'm Kirti Niharika, and my co-author is Ruth G. Lennon. So today I'm going to present my research paper, which is based on investigations into secure IAC practices. All of us are aware that security is important for all the companies, irrespective of the size and type of the companies. And we can say that security is one of the major concerns for companies as attacks are increasing very rapidly. All the types of companies are educating their employees and customers in all possible ways. However, attackers are finding different ways to accomplish their task of breaching the security. So, manual provisioning and configuration of infrastructure can be slow and error prone. It can also reduce the availability of applications to a great extent. Infrastructure can be provisioned manually, as in people can get the physical servers and they can do the whole configuration process manually, but it can incur high costs and it can also cause inflexibility. In some or the other way, the public cloud services like AWS or Microsoft Azure solve this problem. However, for instance, if you want to create a virtual machine in Amazon Web Services, you have to go through multiple pages. Like you have to go roughly through 6 pages in which you have to fill more than 25 fields. So for small infrastructure, it can be fine. But when the infrastructure grows in size, it can become complex. And in that process, many mistakes can also occur. So we say that automated scripts for infrastructure is key to delivery of high quality software, but is it secure? In the year 2017, Amazon Web Services faced an outage costing $150 million due to a defective infrastructure as code script. Security breaches are even more costly, with laws imposing heavy fines for companies without appropriate security measures. So in our paper, we explain how security can be added to infrastructure as code practices. So the problem is, when we consider infrastructure as code, we can ask ourselves, do we consider infrastructure as code as supporting software? Or do we consider the fact that it too is a set of software scripts? Flaws in the code, regardless of the purpose of the software, can enable hackers and attackers to take the advantage, and they can also steal the valuable data and information related to all the users. And we all know that GDPR, the laws like GDPR impose heavy fines. They can impose approximately 4% of the company annual turnover, or the fines in the form of money. Hence, we need to apply best practices by considering security even as early as creating the infrastructure on which the software actually relies. For instance, if average number of security flaws in .NET and Java apps is between 30 and 100 for 10,000 lines of code, why has this level of research not been carried out on infrastructure as code? Work has been carried out on the security of the containers, but code to provisioning the containers may not be tested as well as containers themselves. So we have proposed this system architecture, and the good news is that there are tools and standards which can be used in combination together to secure the entire system, including the infrastructure as code, while never forgetting the Open Web Application Security Principle Top 10, other standards and best practices which should be applied to software, including the more recent standard, the IEEE 2675, DevOps standards for reliable and secure systems, which applies equally to infrastructure as code and the software application which sits on the top. DevOps 2675, the IEEE standard actually says that there can be a conflict between dev and ops teams because the development teams will be more concerned about the process, I mean the security, whereas the operations team will be concerned about the speed. So there can be a conflict. So it is very important to implement security. In this example configuration you're seeing now, architecture security considerations for administrative access, revealing weaknesses in the code, in the comments, strength of the algorithm, use of secrets and IP address, all must be considered. Image scanning in addition to code analysis should be applied to aid assessing the security of the infrastructure as code. As you can see in this image, the code analysis tools performs the vulnerability scanning in the code which the DevOps teams commits, and also it performs the vulnerability scanning on the containers used. So these are the results of the test we have carried out. Many tools were researched for this work. It was found that layers of security tools and their various features combined to provide a greater picture of the security posture of the system. So quality and security gates therefore can be used to ensure that code does not contain any critical vulnerabilities or blockers before moving to the next stage of the process. Only when containers and the related code does not contain major vulnerabilities, then they get pushed for the relevant repository. For the convenience sake, I'm now going to explain this the images which I placed. So in this image, you can see that the tool has scanned approximately 23 vulnerabilities which are high in severity. So we can evaluate all the vulnerabilities, and then we can change the container images, or we can choose some other container images. Whereas in this image, the Sonar Cube, the tool which we used to perform the code analysis, I mean the code scanning for vulnerabilities, it shows us the overall rating of the code which we committed, and it also shows the percentage of risk. In this image, you can see that the Sonar Cube, which is the code analysis tool, not only scans the vulnerabilities, but it also shows what is wrong with that particular line of code, or how it can be made better. In this image, you can see that the all the conditions have been passed. In the sense, we can set the, for instance, if the blocker, if there is a greater than one blocker in the code, you can just stop the process there, then and there itself. Or if the severity is not that vulnerable, we can just proceed with the process. When there are no major vulnerabilities, blockers, and any such vulnerabilities with which the system can be compromised, the process stops. If there are no vulnerabilities in the code or in the containers, we can provision the infrastructure in one of the cloud platforms. So here we selected Linode Cloud Platform to provision our infrastructure. So we say that security is very important for all the aspects of software systems and must be added to IAC pipelines. Implementing security mechanisms and ensuring that they are continuously maintained is responsibility of all the stakeholders in the system. We all know that the Europe's security and data privacy law is considered as one of the toughest privacy laws. Existing and new security standards and regulations prove that implementing security in IT systems is not only necessary, but relatively straightforward. So security steps need to extend beyond simply scanning source code to scanning infrastructure as code, scanning the containers and other system elements for vulnerabilities. Here we say that infrastructure provisioning can become efficient and simple when infrastructure as code is used as opposed to the traditional approach. And automating the combination of tools can improve the security posture, because in the containers there can be some aspects which cannot be found out when we scan the containers manually. So automation in this whole process is very important. So we use the set of tools to scan the uh, source code as well as the containers. I would like to thank Latakin Institute of Technology for the funding and my co-author Ruth Lennon for her support. And I would also like to share my thanks with the host for your valuable time. Thank you. If you have any questions or feedback, I'll be very happy to take them.
Thank you, Kirti. It was a nice presentation, nice work. Which tool have you used in implementation?
For the analysis of source code, we use SonarCube now. We researched many other tools, but we found that SonarCube is providing great features, like it not only scans the code, but also it, as I explained earlier, it also tells us why this is important. We can then go to that particular line of code. We can make it better, or we can change it in some other way. Then we can provision. It also gives us the overall report of how the code is. And when it comes to container scanning, for now, container scanning is not that popular. I mean, it's popular, but there are not tools which are to a great level. So we used a tool called Trivi. It also performs great. It scans vulnerabilities. We tested the system in many different ways. Like we introduced some vulnerabilities into the source code, and we tested the pipeline, and the pipeline actually broke. I mean, it stopped the process because the code has vulnerabilities. And then we also introduced some vulnerabilities into the containers. I mean, we changed the container which is vulnerable. So the tool also performed quite well, and the pipeline process has been stopped. And then we also tested a success test case. I mean, we committed a code which has no vulnerabilities and the containers which is completely safe. And then the pipeline was successfully built, and the infrastructure has provisioned in the Linear Cloud platform.
Okay, thank you. Can you tell a few best practices for securing infrastructure as a code?
Best practices, I would say, it is very important to use the scripts effectively. And it is also important to consider the security in the initial steps rather than the final stages. For instance, I would say infrastructure as code is also good because it, for instance, if you want to provision infrastructure in a development environment, and sometimes you might have to remove some VMs. But when it comes to infrastructure as code, you can just reuse the code and provision the infrastructure as many as times you want. So it is very important that the infrastructure as code script is good. I mean, it follows all the best practices. It is up to the mark as you want the infrastructure.
Right. Yeah. Thank you so much. And all the best.
Thank you.
Thank you, Kirti. It was really nice presentation. And moving ahead, now I would like to call our last presentation. To present his paper on Moroccan Sign Language Video Recognition with the Deep Learning.
I hope you hear my voice. Can you hear me?
Yes, dear presenter, please start your presentation.
Okay, thank you. Hello, everyone, and I will be presenting our paper 3D convolutional network for Moroccan Sign Language recognition. So the outline of this presentation was First of all, I'm going to talk about motivation of the work. Then what is 3D convolutional network? Then I am going to talk through Moroccan Sign Language recognition study. Finally, conclusion. So what is sign language? Sign language are languages like spoken language, but they work using hand and body movement and facial expression instead of sound forming words. So the sign language recognition is the process of automatically recognizing the meaning of the movement and posture, which may be translated into one or multiple words in spoken language. So we proposed a video-based sign language recognition system designed for Moroccan sign language. So the proposed model based on 3D convolutional neural network architecture. So convolutional neural network is an algorithm of deep learning, process the image and identify it based on a certain feature. So they used in every field like image recognition or natural language processing. So there is a steps in convolutional neural network. First is convolutional operations where we touch in feature detector. Then activation functions layer decide where the neuron be activated or not. After that, pooling used to reduce the dimensions of the feature map. Finally, fully connected that layer used to get probability of the input being in particular class. So the model proposed in our paper is based on 3D dimension convolutional network. It taking its input the video frame and output the corresponding class of the input sign. So the architecture is detailed in this table, built with the two convolution layer, two pooling layer, and fully connected layer. So the dataset is in structural sign language video that is used in our experiment. It is an educated material, each word in the video repeated a couple of times. For example, in these three samples, where each video was made at 70 frames per second. So the training and validation accuracy of our model run fourfold as shown in this figure. So as we can see, it's increased during training where it decreased in the loss. That indicated that the model performance is enhanced over time. In this table of the accuracy and loss rate improves between 98% to 99% from the fold, where the loss rate, the lowest value performance of 0.11 taken by the fold one. Then we compared with the state of art, which is as shown in this table, achieved the best accuracy. So to conclude, the Moroccan Sign Language is the official language used by the and family member in Morocco. So we proposed a convolutional network model for Moroccan Sign Language that recognizes it automatically and its performance evaluated on word video, which is significantly improved compared with the state of art. And thank you for your listening.
Okay, thank you, Abdul. What is the size of the database? How many images are there?
We use 54 sign, which their size was 1 gigabyte in the size.
Okay, and why do you want to use CNN for that?
For the training,
Yeah.
first of all, it is easy to it is easy for implementation, and we made a research in the state of art. We found that many people that work with this with convolution.
Okay. Thank you, Abdul. Yeah, that's all from my side. Richa, over to you.
Thank you, ma'am. And we had completed all the presentation, and I sincerely thank our authors and all participants for the excellent presentation and for being there for a part of this international conference. I hope this session was informative enough. And all the presenters would be getting their digital certificates within 2 working days. Further, all the papers has already forwarded to the Springer, and the publication will be live within 5 to 6 months. So kindly cooperate with the team of ICICT. And I would like to also thank our session chair. Thank you so much, ma'am. And I will ask to display the certificate. Ma'am, this is the certificate, and this is a token of appreciation on behalf of Team ICICT and the Global Knowledge Research Foundation.
Thank you, Richa, for the certificate. And I'm really honored to be here as a session chair. Thank you so much.
Thank you so much, ma'am. And there's only one more request. Kindly turn on their cameras for their virtual conference to making this conference more memorable. Thank you so much, everyone.
Nice to see you all.
Thank you, ma'am.
Really wonderful presentations and nice moderation, Richa. Very good.
Thank you, ma'am.
All of you are doing wonderfully, very nicely organizing and conducting all the activities.
Thank you. Thank you so much, ma'am.
I would like to thank Richa, the host, Jay Lalwani, the co-host, and Shailaja ma'am. Thank you.
Thank you. Can I exit now?
Yes, ma'am. Sure, ma'am.